So this is paragraph 3 of the reading Properties of Water. And what are the properties of water? So far we've looked at polarity, and we've looked at surface tension. We've also looked at cohesion. And so let's get on with reading. Water molecules also have adhesive properties. Adhesive properties. This means that they are attracted to other substances that have polar molecules. And we know what polar molecules are. Polar molecules are molecules that have positive and negative charges on them. So we know what polar molecules are. Some common household items that water is attracted to are glass, plastic, soap, bleach, table salt, sugar, and many other things. You can witness the adhesive property of water when you observe the curved surface of water in a graduated cylinder. The upward curving edge of the meniscus is caused by an attraction between the water molecules and the polar molecules of the glass or plastic cylinder. So let's take a look at this for a minute and see what this looks like. We see a close-up view of a graduated cylinder with colored water in it. And here's the important thing to understand about what a meniscus is. If you look at the way the liquid is curved in the glass, the liquid is curved in the glass, not a lot, but it's curved somewhat, and you can see that it's higher on the sides of this graduated cylinder than it is in the middle by just about a full milliliter. This is common and very normal when we measure water or liquids in a graduated cylinder because the graduated cylinder is made of glass, and it just so happens that glass is a polar substance. It has polarity. If the liquid is also a polar substance, then we have the liquid wanting to stick to the glass, and in fact, the attraction between the liquid and the glass is so strong that the liquid will actually climb up the sides of the glass. And depending on the strength of the polarity, you have larger or smaller, or I should say higher or lower meniscus in differing graduated cylinders based on the actual polarity of the liquid and the glass. So the greater the polarity of the glass and or the liquid, the larger the meniscus that you'll have. So here you see a sketch that I created of a graduated cylinder, and basically what I've done is I have done a little zoom in, and so as we zoom in, I've tried to show what the actual water molecules look like and how they behave on the side of this graduated cylinder. So you can see that the water molecules are sticking to the side of the graduated cylinder right here. They're sticking to the side. And not only do they stick to the side, but they tend to climb up the side of the graduated cylinder because the glass has polar qualities. So again, a meniscus is this curved behavior of water in a graduated cylinder. It also happens in a glass, in a kitchen glass, and the water sticks to the side of the graduated cylinder or to the sides of other polar substances because of this quality of adhesion that we're reading about in this paragraph. In this example of adhesion, we see drops of water, all kinds of drops of water, sticking to green plants in all different manners and positions. So we see some here that are on the side. We see this one about ready to fall off. We see these on the surface. Adhesion is water molecules and water droplets, water, sticking to other substances, as you see occurring in this particular photograph. Great picture showing a number of different water droplets sticking to the surfaces of these blades of grass. Continuing on with paragraph 3. And just picking up where we left off, you can witness the adhesive property of water when you observe the curved surface of water in a graduated cylinder. The upward curving edge of the meniscus is caused by an attraction between the water molecules and the polar molecules of the glass or plastic cylinder. This is where we stopped. As the water molecules are pulled up the sides of the cylinder, other water molecules follow. This adhesive nature of water also occurs in plants. Capillary action is when water molecules climb up into the plant's roots and stems because of the polar attraction of the molecules. But other substances such as wax paper do not have polar molecules. You have probably noticed that when water is placed on wax paper, it will beat up in an attempt to pull away from the surface of the wax paper. Oil is another non-polar substance. Water is not attracted to oil. Okay, so how will we understand the adhesive qualities of water? And one thing to remember is that an adhesive is something that glues or connects or binds one substance to another. So if you're wanting to do a repair on a chair that's broken, you would get some adhesive glue and you would put the glue on the chair, you would bind it together with a clamp, and when the glue is dry, the chair would be repaired. Well, in a similar manner, the adhesive qualities of water allow droplets of water to stick to other substances almost as if they're glued in place. So in understanding the adhesive qualities of water, we need to understand that adhesive kind of points us to this idea of water sticks really, really well to other polar substances, the same way water sticks really, really well to other water molecules that are also polar. And then what about this idea of capillary action? Let's look at this a little more closely.